This is the fourth episode of a series where we together implement a library for runtime immutability checks called imcheck. So this will be a very short episode where I just give you some updates on recent changes. I worked on this library for a few hours, but most of this time I spent with the debugger, so I didn't make a lot of changes. So yeah, this will be just a brief update. As you can see, I did a small bit of refactoring, but code is still very ugly and it will require some significant refactoring later on. All I can say that for now we are concentrating on features, not on how it looks or how easy it will be to support this code. Okay, so the main change that I was working on is like support of interfaces. And I added support of interfaces, but I worked a lot on actually trying to generify and work with pointers and interfaces in kind of the same way. And yeah, I almost did achieve that thing, but not entirely. For now, the main problem that we had is that if we have an interface empty interface pointing to the some primitive value, you can't work with this empty interface in the same way as you work with actual pointer, because if you take an element later on, um, you won't be able to get an unsafe pointer to this element. So that's why I changed the function that we use to recursively calculate value snapshots. And now specifically for work with interfaces, we pass the previously resolved pointer value to the later on stage, and we use that one if it was passed from upstairs. I know it sounds horrible, but if you have some time, if you want to play with it, you can actually maybe check out this code. I will attach the link to this PR to the YouTube uh, video description. And then, if you find a better way to deal with this thing, that will be great, because I spent like a few hours. Maybe there is better way, but so for now, what I'm doing is that when I'm trying to resolve the pointer value of this reflect value, I check if it's a pointer. I will just do value pointer. And if it's, I'm sorry. Yeah. And if it's interface, I do this kind of very dirty hack when I have an interface data, which is an array of two uint pointers, and I take the second element of it, which is actual pointer to the data, and I cast it to unsafe pointer. So for now it works like that. This actual cast fails on check pointer verification. That's why I added no check pointer. But for now, all these cases are working fine. I'm not sure if it's going to if this hack is going to stay or not, but for now it is what it is. Yeah. And that's it. I think that's it. That's how we support interfaces. I also added a detection of loops and just recursive pointers to the same structure. So here's the bunch of test cases that we have now. We have a linked list test case, but we also have a test case for recursive linked list, where you can see I have a tail pointing to head and head pointing to tail. So this thing without this check, we can even, if I disable it and we run it together, we will get, as you can see, runtime Gordon's stack exceeds the bytes limit. And yeah, this is the actual stack that we got. Yeah, as soon as we add this check where we verify that we already visited this pointer, so we're not gonna capture this pointer and verify checksum of its element, this thing just works and it detects this change that we made to the tell value. So it says, okay, it was 1, now it's 4. Yeah, that's it. I also added a bunch of support for like null values, nil values, zero values of arrays and slices and all this stuff. So now we have like this more sophisticated test case that has a kind of a pointer to the slice of empty interfaces where every element it's also like different, has different type. So yeah, and here we basically mutate a byte slice inside of this deeply nested structure, or maybe not so deeply, but nested structure. And if we run it, you can see that we have, yeah, we detected a mutation, yeah, here. And snapshots will tell us where this mutation happened. And as you can see, with all these features, we can actually, using SPEW library that we use for capturing snapshots, we are able to show even like string content of the byte slices that we have. Okay, that's it. And what else? I also changed, like, did a small improvements to the user experience. So right now, when we print these checksums, we print like exact type of a pointer, or how exactly we, yeah. So for example, this was an interface with this address, and here is the checksum of this interface, and this is yeah, and this is the same pointer basically, but interpreted as an integer, and I think it refers to this case. Yeah. So yeah, now we print hex values of actual addresses, and what the reflection kind value we print as a string, so it's easier to understand. We don't need to refer to this enum inside the reflection library. Yeah, and that's it. That's all changes. I think the next time we will work on support of maps and maybe functions as well, and after it we will start to do some immutability evaluation options. Yeah, I think that's it. Thank you for your time and see you in the next episodes.